Hello everybody, today we are going to talk mainly about video quality metrics. They can be also applied to images, but we are going to focus on video and we are going to talk about video all the time. First of all, we need to define what is a video quality metric. And it's the quality always of a compressed and then decompressed video sequence. And we are going to measure the quality of this sequence compared to the original one. Therefore, we cannot compare different video sequences, with the quality of different video sequences. We can only compare different versions with different qualities or different configurations of the same video sequence compared to the original one. Regarding the metrics, the first one is the mean squared error, which actually measures an average of the square differences of all the pixels that we contain in an image or in a video. It's very simple, and in this case, of course, the lower the better, because it's the difference. Then we can define also two more metrics, which are the signal to noise ratio, SNR, or peak signal to noise ratio, PSNR. In this case, the greater the better. The SNR, it's basically a comparison on how good is the original sequence compared to itself, divided by how good is the decompressed sequence compared to the original one. So it's like a ratio, as its name says. It's signal, the original, to noise, the decompressed ratio. In this case, it is measured in a logarithmic scale, so we apply the logarithm, and the typical unit is in decibels, so just to make it deci, we multiply here by 10 as well. But the most common one is the PSNR, the peak signal to noise ratio, in which instead of comparing the quality in the numerator of the original sequence with itself, we consider like the best case, which is that all pixels are white, which is 255 elevated to 2. Okay, this is, as I say, the most common metric for measuring video or image quality, the PSNR. So here we are going to compare the quality of 3 different frames or 3 different images. Here, first of all, we always need to define the original image. We can see, of course, maybe the quality is not the best, but we are always going to compare the other versions with this one. Then we have this image, which is compressed and then decompressed, and the final measure with PSNR that we obtain is around 30 decibels. And then we have another version in which the final quality is around 28 decibels. We can look at these images and we can see that, of course, the details in this picture are better than the details in this other picture. Okay, the last one here, this one is a little bit more smoother than the other one. We have lost more details because of this compression process. However, we have a problem with this kind of signals, because we are comparing all the time every pixel with the one which is located in the same position in the original picture. So what happens here? Actually, this image has only been mirrored. We have not lost any kind of quality actually. So of course this one compared to the original one has a quality of 50 decibels, but this one has a quality of only 15 decibels. So what happens here? What happens is that we have performed a mirror. Then of course, the pixels are not located in the same position. Then when we compare the pixels, the result is really bad, even if visually the result is very good. So PSNR faces this kind of problem. Anyway, as I said, is the most commonly one that is being used nowadays. Okay, as I said, this one is just horizontally mirrored. So these metrics, the mean square error, the SNR and the PSNR, are objective quality metrics because we are obtaining a value objectively. Sometimes we don't want to just focus on objective quality metrics, but like for instance in this case we want to measure how good the picture or the video is for my human visual system. Of course, there are more objective metrics for video content, which are even better than PSNR. We are not going to study them because, as I said, actually the one that is being used nowadays is PSNR. But we also have subjective quality metrics like mean opinion score. What does mean mean opinion score do? What it does is that, of course, we have here the original video sequence and then the compressed and the decompressed video sequence. And then we display both sequences to a viewer. The viewer is asked to score how good the second sequence is compared to the first one. And the viewer needs to score from 1 to 5, 1 being bad and 5 being excellent, or 1 being very annoying and 5 being imperceptible, how good the compressed signal is compared to the original one. Here we always need to tell the viewer that, of course, be careful, because if the original one is really bad and the second one is actually as bad as the first one, then it's a 5. So here what we will obtain is a metric from 1 to 5 on how good my video sequence is. The problem with this metric is that just one viewer is not enough, because we need more viewers to get a confidence interval. Therefore, this metrics has the disadvantage that we need many viewers to watch the sequence. And usually it's not just a sequence, of course they are pairs, the original and the compressed one, and then we also present them many sequences. Other metrics that we can use is, of course, the compression ratio is like, because the previous ones were about quality, now we have other metrics. Compression ratio is just to measure how effective the compression process resulted. It's simply the size of the compressed file divided by the size of the original picture, video, or even audio multiplied by 100, so that we obtain a percentage. Then we also have the bits per pixel. It's like how many bits per pixels do we have in the compressed sequence divided by the original number of pixels. So this will return how many bits do I need for every specific pixel. And finally, also very related to the compression ratio, we have the compression factor, which is expressed as f to 1. For instance, if we have 2 to 1, means that 2 bits in the original signal only need 1 bit in the compressed signal. It's actually the half of the original size. 3 to 1 is a third of the original size. 10 to 1 is 100th of the original size, which means that in the original one I needed 100 bits, and in the compressed one I only need 1. And to obtain the f, it's very simple. We just need to apply the size of the source divided by the size of the compressed file. It's more or less the opposite as we have here in the compression ratio. So that's it for today. I hope that you have all the concepts about the metrics that we are going to use to measure how good and or how effective our compression is with pictures, video, and audio. Thank you very much for your attention.